All right, we are starting Unit 2, Section 1. This is Objective 2.1A1. The objective is the student will be able to simplify radical expressions. Just as a reminder, expressions do not have an equal sign, so we are simplifying, we are not solving. We're starting off with a few examples of radicals. I have the square root of 36. This is going to equal 6 because 6 squared equals 36. The square root of 0 equals 0 because 0 squared is 0. The square root of 4 over 49. This is the same as taking the square root of 4 and the square root of 49 individually. So the square root of 4 is 2 and the square root of 49 is 7. This means that when you square 2 over 7, you're going to end up with 4 over 49. Because when you square a fraction, the exponent goes to the numerator and to the denominator. The square root of 0.25. Now, obviously, this is a little weird. It's not a whole number. You're going to get a decimal, and that's fine. The square root of 0.25 is going to be 0.5 because 0.5 squared equals 0.25. I have the square root of x to the power of 6. This is going to equal x to the square root, or x to the power of 3. The reason for this is when you square x to the power of 3, these exponents multiply. So this is really x to the 3 times 2 power, which is x to the power of 6. For example, 6, I have the square root of 9x to the power of 12. So again, this is going to be like I'm taking the square root of 9 and the square root of x to the power of 12. I know that the square root of 9 is 3. And the square root of x to the power of 12, if we remember back from example 5, we are basically cutting it in half. We had x to the power of 6, and I ended up with x to the power of 3. So the square root of x to the power of 12 is going to be x to the power of 6. And this is because when you square 3x to the power of 6, the exponent goes to the 6 and to the 3. So it's 3 squared times x to the 6 times 2 power, and that is 9x to the power of 12. Last up here we have the negative square root of 81. So this is going to be the negative square root of 81. The negative is on the outside, and that's fine. If we look inside, I have the square root of 81, and I know that that is 9. So it's okay to have a negative on the outside of a radical, but if I had something like the negative square root of 81, this does not equal negative 9. These are two different things, because negative 9 squared is positive 81, not negative 81. So I cannot take this square root. This does not give me a real number. If I look at our next section, I'm dealing with cube roots. Cube roots are when you multiply something by itself 3 times. So for example, example 1, we have the cube root of 1. This is going to equal 1 because 1 cubed is 1. The cube root of negative 64. It is okay to take the cube root of a negative number. The cube root of negative 64 is negative 4. That means that negative 4 to the power of 3 is negative 64. Because negative 4 times negative 4 times negative 4 is negative 64. Negative times a negative is positive, so these negatives would cancel out with each other, but it still leaves me with this extra negative. That's where the negative comes from. Example 3, I have the cube root of 8 over 125. So this is kind of the same idea as back in example 3. These are kind of the same idea. I'm going to take the cube root of 8 and the cube root of 125. The cube root of 8 is 2, and the cube root of 125 is 5. This means that I should be able to take 2 over 5, raise it to the power of 3, distribute that exponent, and get 8 over 125. If you're not sure how to put a cube root in a calculator, what you can do is write down your numbers. So for example, if I'm taking the cube root of 8, I can say that in my calculator I could type 8 raised to the power, that little caret button, of 1 divided by 3. That would give me a cube root. You could also hit second and find the button that has a little x and a square root symbol. And then you can type in your 3, hit second, that button, type in your number, which in this case we're using 8, and it would pop out 2. Okay. Back to our examples, I have the cube root of x to the power of 6. Basically, when you're taking the cube root of this, you're dividing 6 by 3, and you're going to end up with x to the power of 2. That means when you have x squared raised to the power of 3, these two exponents are being multiplied together. So this is x 2 times 3, and that is x to the power of 6. The cube root of negative 27 x to the power of 9 is going to be a negative 27. The cube root of that is going to be 3. 3 times 3 is 9, times 3 is 27. The cube root of x to the power of 9 is going to be x to the power of 3. And that is because negative 3 times x to the power of 3 cubed is negative 3 cubed times x to the 3 times 3 power, which is negative 27 x cubed, or pardon me, x to the power of 9. In this next section, we're finding the n root of a raised to the power of n. So n just represents a number, a represents a number, they're just variables here. There's two rules we have to look at. If n is a positive number, then you take the nth root of a to the power of n, it's going to equal the absolute value of a. If n is a positive odd number, then n to the power, or pardon me, the n root of a to the power of n equals a without absolute value. So I know that these two sentences look very confusing. It's actually fairly simple. Okay, so we're going to go ahead and get started with that. I have example 1, the square root of negative 3 squared. So with a square root, what you don't notice a lot of the time is there's actually a little 2 here. In this example, n equals 2 and a is -3. If I look at my rules, the first line it says, right here, it says if n is a positive even number, which it is, n is 2, that's positive and even, then the nth root of a to the power of n equals the absolute value of a. Okay, so I need to set this equal to the absolute value of a. I know that a is -3. If I take the absolute value of -3, it's going to give me a +3. So I know that the square root of -3 squared equals +3. For the second example, I have the square root of x squared. Again, with a square root, there's always a little 2 right there. Here, n is 2, and a equals x. Again, n is a positive even number, so again, we're referencing this first line right here that says if n is a positive even number, then the nth root of a to the power of n equals the absolute value of a. So I know I need to find the absolute value of a. A is x, so the absolute value of x equals +x. So this means the square root of x squared equals the absolute value of x. Which is just x. Moving on, I have the fourth root. So once you get past squareds and cubes, you just call it by the number. I have the fourth root of x minus 2 raised to the power of 4. Okay, in this case, n equals 4. And a is actually what's in the parentheses. A is that whole inside piece. A is x minus 2. Well, n is positive and even, so again, we are looking up here at this first line, and I know that I'm going to have to find the absolute value of a. A is x minus 2. The absolute value of x minus 2 is just x minus 2. So, the fourth root of x minus 2 raised to the power of 4 is the absolute value of x minus 2. And I should not have erased those up there. Okay, we have the cube root of -5 cubed. Here n is 3, and a is -5. Now we're looking at this second line. If n is a positive odd number, then the nth root of a to the power of n equals a. So, in this case, a is -5, and that means the cube root of -5 cubed equals -5. Lastly, we have the fifth root of 2x minus 7 raised to the power of 5. Well, n is 5. And a is 2x minus 7. So if I look at that second rule again, n is positive and it's odd. So I know that the nth root of a to the power of n is going to equal a. So I have the fifth root of 2x minus 7 raised to the power of 5 is going to equal 2x minus 7. lastly, we have some functions that we're going to work with, just working on remembering how to plug things in. I have f of x equals the square root of x minus 4, and g of x equals the cube root of x plus 2. We're going to find each function's value. So first off, I have f of 8. Well, I know that f of x equals the square root of x minus 4. But in this case, I'm going to plug in 8 for x. So 8 just took the place of x. So f of 8 equals the square root of 8 minus 4. 8 minus 4 is 4, so f of 8 equals the square root of 4. And the square root of 4 is 2. For example 2, I'm trying to find f of 6. I have f of x equals the square root of x minus 4. I took out the x's and I put parentheses in their place. I'm going to plug in 6, just like in the last problem we plugged in 8, and I'm going to simplify. I have f of 6 equals the square root of 6 minus 4. 6 minus 4 is 2, so f of 6 equals the square root of 2. I can't simplify that at all, so that's as far as I can go. Example 3, I have g of negative 1. I know that g of x equals the cube root of x plus 2. Again, I'm taking out the x's and I'm putting parentheses in their place, so I know exactly where to plug in those numbers. Here I have negative 1. So g of negative 1 is going to equal the cube root of 1. The cube root of 1 is 1. And that's as simple as I can make that. Last example, we have g of x equals 3, or the cube root, of x plus 2. I know that I'm taking out the x's and I'm putting parentheses in their place. I'm going to plug in 1. And I have g of 1 equals the cube root of 1 plus 2. 1 plus 2 is 3. So g of 1 equals the cube root of 3. If I take the cube root of 3, I'm not going to get anything but a decimal. And I'm going to go ahead and leave my answer as is instead of writing in the decimal, just like we did for example 2. Okay, so this has been objective 2.1a, simplifying radical expressions.